Hi, I'm Ms.Matsuoka, and I'm going to teach you about how to expand logarithms. So, we're going to look at our 3 logarithm rules first. So this is our first logarithm rule. We have 2 things inside that are multiplying, and they're going to end up breaking up into 2 different logarithms that are adding together. So let me show you a different example here. So we're going to have log base 2 of 3x. This is going to become log base 2 of 3 plus log base 2 of x. So notice how all the bases stay the same, and the only thing that's changing is they're breaking up or expanding them into more logs, and that's what it becomes. So yeah, the purpose of expanding is to break it up into as many logs as possible, so that's kind of what's happening here. This is our second rule. When you have things that are dividing, they're going to end up breaking up into subtraction. So, if I have log base 2 of 3 over x, that's going to be log base 2 of 3 minus log base 2 of x. Actually, let's make this a little bit more interesting. I'm going to make it more interesting by erasing the 2's here. Now if I don't have a base, this really just means base 10. So this is base 10. It's important for you to know that just because if you don't see a log with a base, it's just going to be base 10 automatically. This one, we have an exponent. Now the exponent, when we expand it, comes down out in front and it multiplies. So for this one, I'm going to show you a different kind of log. It's going to be ln of a to the, oh sorry, not a to the x. Let's do 2 to the 3rd power. We're going to make it 3 times ln of 2. Ln is just another log, it's log base e, and so yeah, ln is just log base e, sorry not 3, it's e. And log base e, like e is just a number, e is a number, it's kind of like pi. It's like 2.72, so you know, it's just a number, ln, so that's another form of logs. So now we have our 3 rules, and we're going to go apply all 3 of these rules to our problems over here. So here's our first example problem. As you can see, there's a lot of stuff that we are doing here. We're multiplying here, we have exponents, and we're dividing. So we are using all 3 rules. What I'm going to do first is I'm going to work with the multiplying and dividing first, because to me those are the most obvious ones, and then I'm going to break it down a little bit more. So here's our first step. We have ln of 33 times, well this is really 33 times x to the 5th. So I'm going to say plus ln of x to the 5th, because that's our first rule. And now I see this division, so it's going to be minus ln of y to the 7th power. Okay, I can break down this 33 more. I can break it down into 3 times 11. So I'm going to go ahead and do that. So it's going to be ln of 3 plus ln of 11 plus this 5 comes out in front to multiply, 5 ln of x minus the 7 comes out in front to multiply, 7 ln of y. And that is my answer. I cannot do anything else to this. Alright, let's look at our next example. So here's our next example. Again, I'm going to split it up into multiplying and dividing. So we have log, and again, this is base 10, right? So log of 27, that's going to be plus log of the square root of x. And the square, well, actually, yeah, let's go ahead and write the square root of x. We're going to change that in a little bit in our next step. It's going to be minus log of y. And this one, even though they're multiplying, it's going to be minus because it's still dividing the whole thing. So it's still dividing all of this stuff. You can also think about it a different way. Everything that's in the bottom has a negative exponent, right? Because it needs to be flipped to go to the top. So this is still a negative here, so it's minus log of z squared. Alright, now we're going to break stuff up a little bit more. So it's going to be log Now I can write 27 as something with a power. I can write it as 3 to the 3rd power. So I'm going to do that. It's going to be 3 to the 3rd power here. This square root I can also write as a power. Now the square root is the power of 1/2. So like the cube root is the power of 1/3. Any like fraction exponent, the denominator is going to be the root that you're taking. So it's going to be x to the 1/2 power here. This is still minus log of y. I can't do anything there. And then here the 2, we're using that 3rd rule, comes out in front and multiplies. So 2 log of z. Alright, let's look at simplifying these two lastly. So the 3 comes out in front, so it's 3 log of 3 plus 1/2 comes out in front, 1/2 log of x minus log of y, oh sorry, not x, y, minus 2 log of z. Okay, and that is our answer here. Okay, and let's look at our last example before the bonus question. So here's our last example. We're going to, again, do the multiplying and dividing first. So we have log base 2 of, it's going to be the 5th root of x squared. Again, these are all in the bottom, so they're all going to be minus. So minus log base 2 of 2 minus log base 2 of x to the 5th and minus log base 2 of y to the 12th. Okay, let's look at this one here. Remember, any root is that fraction exponent. So this is going to be log base 2 of, and this is going to be x to the 2/5 power. Right, 2 is the normal exponent, 5 is the fraction one. This right here, we're going to talk about this right now. So log base 2 of 2. Now if you convert this to exponential form, you're going to get 2 to the x power, right, because we don't really know what that actually equals right now, we're trying to figure that out, is equal to 2. Now x would be 1 in this situation because 2 to the 1st equals 2. So we actually know what this is, it's just 1. So this is minus 1 here. And then let's see, this one is going to be, the 5 comes out in front, so minus 5 log base 2 of x. The 12 comes out in front here, so minus 12 times log base 2 of y. Now one last thing is we're bringing that 2/5 down out in front. So it's going to be 2 over 5 log base 2 of x minus 1 minus 5 log base 2 of x here minus 12 log base 2 of y. Now if you wanted to, and you don't necessarily need to, but if you wanted to combine these two, because they're kind of like terms, you have this 2/5 log base 2 of x and this minus 5 log base 2 of x, you could do that. You know, you just have to get a common denominator and work with it that way. So let's go ahead and do that really quickly. So I'm just going to do some work on the side here. We have like this, basically we have this 2/5 minus 5. I'm just going to ignore the logs for now because they're going to be in there, but let's work with the fractions. So this is over 1. We're going to get a common denominator, so I need to multiply the top and the bottom by a 5. So this is 2/5 minus 25 over 5. So in total that gives me negative 23 over 5. So over here, in total I have a negative 23 over 5 log base 2 of x minus 1, and then minus 12 log base 2 of y. Okay. So there are a couple things that I think I should highlight here. So first off, what we did over here is really important. So this is one of the reasons we want to break up the logs as much as we can, because there's sometimes we can simplify more. So here, this log base 2 of 2, all I did was I said, okay, log base 2 of 2 is equal to x. I converted this to exponential form here. After I convert it to exponential form, I'm just looking to see what x is. Like I'm looking to see what this whole thing actually equals, which is what my x is. So I'm looking to see what the whole thing equals. We figured out, oh, well must be equal to 1, so that's why this was 1 here. And then down here, I notice I have like terms, because they're both log base 2 of x, so then I'm just really subtracting those coefficients, which is what we did over here, and we got like a common denominator and all that stuff. So anyway, that is our last example problem. Here is your bonus question. So I want you to expand that. Good luck.